this is the, sorry. We're talking about the Aligned project. I am Patrick Ruimerman, as I said, from BTG. This is an EU project, and yeah, I like to give some general ideas about general presentation on what we try to do with this project. I work at BTG. BTG is an SME that works on energy and materials from biomass. We have a combination of consultancy and RTD, mostly linked to bio-based conversion processes and applications, and on thermochemical biomass conversion. We have a lot of experience, 25 years, and also in a rather wide field with respect to biomass. So we do work from pre-feasibility up to implementation. We work from logistics, pretreatment, conversion. We also know quite some things about gamma aspects, such as the sustainability. And we like to work with partners in EU projects or in similar consortia where you try to accomplish something together with others. Why did we start with the Aligned project? The roots for the project was that we carried out a study for the European Commission on biorefineries outlook for deployment. And then we looked at the barriers for the use of bio-based materials in the chemical industry. And lack of evidence on sustainability was seen as a big barrier by a number of stakeholders. We did some interviews, and there were all kinds of problems emerging with sustainability issues. It turned out that proving it is costly. You often need a full life cycle assessment, an LCA, on a product level. So for each product, a different one. These LCAs are open to interpretation sometimes. There is no level playing field with fossil competition. The requirements are often less stringent there. There are many labels which are not always effective or not always clear. There are very much a large amount of sector-specific methods, like the Higgs MSI in the textiles, and the terminology is confusing. Now, there was a call written out by the European Union where this could be addressed, and we formed a consortium with a number of partners. And what we do, we want to try to improve the environmental sustainability in bio-based sectors directly and by improving these methodologies. So that's actually the background of the project. So the rationale of this is that we want to improve these bio-based processes in these industrial bio-based sectors. They have a promise of improving the environment in Europe, restore biodiversity, protect air, water, soil, etc. But I mean, that needs to be done and that needs to be proven. So they issued this call in these 5 sectors. The textiles is one sector of that because, of course, I think most of you know that the environmental sustainability is really an issue there. And we are one of 2 projects which were selected for funding. So we would like to help the LCA field so that the measurements of the environmental impacts for these in the textile sector and in all the other sectors is improved. And we hope that this is a better decision-making tool towards sustainability. We try to do this by improve, harmonize, and align the LCA methodology for in the bio-based industries. We want to demonstrate it, and we want, and this is the third part, and this is also why we have this this workshop. We want to involve, inform, and empower relevant stakeholders so that we get a good uptake of the methodology and that we do what the sector wants us to do, what is perceived as real problems by the sector. How do we do that? But this is a bit of a complicated chart. Yeah, but if you start from left to right, you see roughly what we try to do. And we take the state of the art. We try to harmonize and find scientific consensus on the environmental sustainability assessment. We make a methodological framework and we make 5 case studies, 1 case study per sector. We have an iterative analysis and improvement and a communication and feedback with the stakeholders. And we hope, of course, to get better aligned methodologies and improved environmental sustainability. What we hope to achieve is aligned and simplified methods to assess environmental performance. We hope to improve the environmental performance in the industrial bio-based sectors, and we hope to disseminate the data on this environmental performance and recommend improvements so that they can fulfill the promise which was mentioned earlier in the slides. These are the results. As I said, improve environmental performance, align it and simplify it. This will hopefully lead to costs reduction in LCA methodology, better strengthened LCAs in an open science environment. That should lead to better information for policymakers, avoidance of mistakes which were made in the past on the environmental performance. And that should all lead to increased growth of circular bio-based systems. The project, the partnership is quite a nice and synergetic system. Here we have a number of academic partners, universities, such as the University of Aalborg, which is the coordinator of the project, University of Antwerp, a French university, and a Norwegian university. We have, for each case study, a dedicated company with a process which we hope to improve. And we have some research SMEs, BTG and Sustainable Innovations, and 1 sector organization in the textile sector, the Belgian organization Textiles. In our case study, we focus on a improvement which is championed by the industrial partner Textiles. The other partners are Textiles and BTG. And we focus on a case which is very nicely called Dr. Green. It's about making recycled projects from used end-of-life hospital garments. The idea there is that industrial garments, they are relatively uniform. Usually they consist of polyester and cotton, a combination. And in the process of Utexpel, they are able to separate those. The polyester can be reused, the fibers, and the cotton dust, they don't have a good application yet, but it could be used as input for chemical recycling. The process works as follows. When it is collected, the process, it is removed, the hard and the colored parts are removed. They're thinking of using a social workplace for that. Then via a shredder and spinning, weaving, dyeing and finishing, new garments can be made so that you use less material. There are of course questions and considerations. The cotton dust was already mentioned. The colored garments, it's not that there yet, but if sufficient homogeneous material batches can be collected, that should be a possibility. A question is the material efficiency. Can things be automated? And what to do with multiple recycling stages? Would it then still work? We are working on this case study. We're looking at the environmental sustainability. And yeah, we hope to be clear what it is. Yeah, we expect that the impacts are less water and fertilizer use because organic cotton is used. Less use of virgin material because you're recycling. Local production with short supply lanes, so less transport, less emissions associated to transport. The social workshop is a social component, which could also, in a social LCA, could be beneficial. So we will look at it. We think that these are the benefits. We hope that that comes out of the study, and we want to use the results of the study to improve this project, of course. Then going back to this workshop. This workshop fits in a consultation process, which we do for all the sectors. We have made a sector overview. Marissa mostly has made that. She will present that in a few minutes. And we would like to know if we have the problems in the textile sector with environmental sustainability, if we have them sharp in focus, and what we can do to improve the environmental sustainability and what we can do as project to assist the sector with that. We do that. We gather feedback in two ways. We have done an online consultation. Results will also be presented in this workshop. And we do that with this workshop. Near the end of the project, in about 2 years, we hope to have a lot of results, and we hope to present that again to you. You are already warmly invited to that next workshop in about 2 years. Good. We do, of course, we are reachable on various ways, LinkedIn, Twitter, etc. Connect with us, be a stakeholder so that we can involve you and inform you on our results. You're warmly invited for that. So thank you. And this is my presentation. Are there any questions or comments before we go to Marissa? No? Okay, then I close it off, and I would like to give the word to Marissa with her presentation on the sector status.
Okay, well, thank you, Patrick, for that nice introduction. Let me share my screen. Perfect. Do you see my screen?
Yes.
Perfect. Okay, well, welcome everyone. I will tell you something about, my name is Marisa Groenestegen. I also work at BTG, and I will tell you something about the textile sector. So why did we write the sector overview? As my colleague has already explained, in the Align project, we are looking at LCA methodology, specifically in the bio-based sectors. And in order to test this LCA methodology, we are having a case study for each sector. So as was said before, we are looking at the Dr. Green products in this case study. But in order to translate our learnings from this case study into recommendations that fit the entire textile sector, we need to gain more knowledge on the European textile sector, its materials and its recycling processes. So the first step was to write a sector overview, of which I will share the key findings with you today. And you should all find this document in your email as well. And this overview aims at describing the current state of the sector and its materials, especially the bio-based materials, as well as their environmental impacts and the ways that these impacts are assessed, but could also be minimalized. So in order to dive deeper into these results, we recently had online consultations, also one for each sector, in which we wanted to find out what the people from the sector find most important. Um, However, these online consultations are, of course, very limited, which is one of the reasons why we are having this workshop, so we can get a bit deeper into the results. But again, we want to know what is most important according to people from the sector, and why they find this most important. But also we want to keep you up to date with our findings up to now, and get your feedback on these findings and verify our results. So all in all, our goal is to get recommendations about LCAs that fit the entire textile sector. Okay, so let me start. The EU textile sector plays a big role in the European manufacturing industry and has a turnover of over 166 billion euros, of which the highest is in Italy and Germany, which together account for almost half of this turnover. The sector employs 1.7 million people, and globally, the textile sector is the third largest employer after food and housing. So in 2019, there were 160,000 firms in the sector, of which they are mostly small businesses, as 90% of these firms have less than 50 employees. So the EU produced 6.9 billion tons of finished textile products in 2020, as well as intermediate products for textiles such as fibers, yarns, and fabrics. And the textile and clothing sector is also very globalized, as the global market accounted for 38% of the EU turnover. So European households consume large amounts of textiles with an average textile consumption of 15 kilos per person per year, of which 6 kilos consists of clothes. And this amounts to an estimated total consumption of about 6.6 million tons of textile products per year in Europe. And European households spend on average 600 euros on clothing per year, as well as 150 euros on footwear and 70 euros on household textiles. So why do we look at textiles in this project? Cotton fibers accounted for 22% of the global fiber market in 2021. And historically, cotton has been one of the most popular materials in the textile sector. However, as this graph shows you that by 1995, the production of synthetic fibers surpassed that of plant-based fibers, which is around the same time that the term fast fashion first emerged, in which a lot of polyester is used. And currently, or as of 2021, polyester accounts for more than half of the fibers used. As you can see that it accounts for 54% of all fibers produced globally, and all other fibers account for 46%. So global fiber production has quadrupled in the last 50 years. While a part of this can be explained by population growth, the increase in fiber production is largely due to an increasing consumption of textiles per capita, which has almost doubled in the last 50 years. So similarly, the number of times that a garment is worn has decreased with about 40% in the last 15 years. And both this increasing textile consumption and the declining clothing utilization rate are largely due to the uptake of fast fashion. So fast fashion has led to a quicker turnaround of new styles and has more collections offered every year. So fast fashion goods often have lower prices and lower quality, and the fast fashion industry is dependent on cheap synthetic fibers, which has caused a spike in the demand for fibers such as polyester and polyamide. And as can be seen in the graph, the production of synthetic fibers is now more than 7 times higher than it was 50 years ago. So if we look at global fiber production, um, it totaled 113 million tons in 2021 globally. And the figure shows that the largest share comes from synthetic fibers, which is about 64%, which is followed by plant-based fibers with 28%, man-made cellulosic fibers with 6%, and less than 2% is from animal fibers. So the synthetic fibers are mostly polyester, as well as polyamide, polypropylene, acrylics, and elastane. The most commonly used plant-based fiber is cotton, which is followed by jute, coir, flax, and hemp. And of the man-made cellulosic fibers, viscose, sometimes also called rayon, is most commonly used, followed by acetate, lyocell, tupro, and modal. And more than half of these of the animal fibers produced globally are sheep's wool, followed by down and silk, and some small shares for mohair, cashmere, and alpaca wool. So again, why do we look at textiles? So the sector is the largest emitter of greenhouse gas, is a large emitter of greenhouse gases. And its total emissions totaled 1.2 billion tons of CO2 equivalent in 2015, which is more than the emissions produced by the maritime and aviation sectors combined in the same year. So the textile sector consumes about 4% of all fresh water extracted per year. So in 2017, the sector used about 93 billion cubic meters of water, which is enough to meet the consumption needs of 5 million people. The sector's water use is expected to increase by 50% by 2030, and climate change is expected to increase water insecurity in many regions of the world, especially in many Asian countries that are important to the global textile production. So this can lead to major issues with water scarcity. The textile sector is also a major consumer of fossil fuels, as in order to produce 1 kilo of synthetic fiber, 1.1 kilos of petroleum oil is used. So while the sector now uses about 100 million tons of petroleum oil, this is expected to triple to about 300 million tons in 2050. There is also a lot of chemicals that are used to produce textiles, as this is about 400 grams of chemicals per kilogram of synthetic fibers and 900 grams per kilo of cotton materials. There are also issues with land use, as an estimated 5% of the world's cultivated land is dedicated to producing fibers or materials for the textile sector, and this is expected to increase to 7% in 2030. So there are also, of course, issues with microfiber release. So fibers are released in the environment during the production, the use, and the end-of-life disposal of textiles. So synthetic fibers with a length of under 5 millimeters are also known as microplastics, and the majority of microplastics from textiles are released during the first washes of textiles. So the spread of fast fashion has led to more first washes, as these clothes are usually worn out pretty fast and only worn for a short time. So more clothes are being used and there are more first washes. And these microplastics end up in various ecosystems, especially in marine environments, such as shorelines, waterways, and oceans, and are being ingested by all types of living organisms and are impacting these ecosystems as well as human and animal health. So there's also the issue of end-of-life waste. So large amounts of clothes are being produced and quickly worn out, which generates large amounts of waste. And only a small share of textiles get recycled, but the far majority of textile waste ends up in landfills or being incinerated. So next to the environmental impacts, there are also social impacts, as the textile sector is quite labor intensive. So worldwide, the textile sector is the third largest employer, and most of the textile production takes place in Asia, where lower costs and lower cost of production as well. It has come at the expense of the workers' safety and health. So in 2013, a garment factory in Dhaka, it collapsed, resulting in the deaths of over 1,000 people. And this event has served as a wake-up call for the global fashion industry to operate in a more sustainable manner, which doesn't only focus on the environment, but also on social impacts. So the textile consumption has been identified as the fourth largest impact on the environment after food, housing, and mobility. And textile consumption also inflicts the third largest pressure on water and land and is a major driver of greenhouse gases and resource depletion. So as such, one of the major challenges of the textile sector is the need to be less wasteful and to use less resources. So in order to contribute to more sustainable operations, the use of renewable raw materials is important, namely the use of natural and other bio-based fibers. Um, so what types of natural and bio-based fibers are there? I will give you a short overview. So there are various plant-based fibers, and as I mentioned before, this includes cotton, jute, flax, hemp, there are also animal-based fibers such as wool, cashmere, alpaca, down, silk, and mohair, and man-made cellulosic fibers, which are produced using types of wood, but also from bamboo, soy, sugarcane, and can also be produced from cotton linter. Then there are biosynthetic fibers, which are created using sugar and starch crops, such as sugar beets, corn, wheat, cassava, and also oil crops, such as castor. Then there are also the synthetic fibers, which are made from petroleum oil, which includes polyester, polyamide, elastane, acrylics, and polypropylene. And these fibers can then be spun into a yarn, and this yarn can then be weaved and knitted to create a fabric. This fabric can then be used to create, or it first has to be finished and dyed, and can then be used to create various technical applications. So there are a lot of different technical textiles which are being used for industrial purposes. And it could also be used to make garments, which includes various types of clothes. And there are also home textiles such as curtains or bedding. So it should be noted that bio-based does not necessarily mean that it is more sustainable. So if we look at cotton, we can see that its production has major environmental and social impacts. So cotton crops cover 2.4% of the world's cultivated land, but use 4.7% of the world's pesticides, as well as over 10% of the world's insecticides, making it one of the most pesticide-intensive crops. So to produce enough cotton for one t-shirt, an average of 17 teaspoons of chemical fertilizers are used, and nearly 1 teaspoon of active ingredients, such as pesticides, herbicides, and insecticides. And these pesticides do not only have a negative effect on the environment, but can also have serious impacts on the people that are working with them. So 2 in 5 cotton farmers are said to have pesticide poisoning in the last year. The production of cotton has also depleted and degraded the soil in many areas of the world, and has polluted both water and soil with its heavy use of pesticides and fertilizers, which can impact the local communities. Furthermore, the crop also requires a lot of water to grow. So per kilo of cotton produced, 10,000 liters of water is used. And global cotton production requires more than 250 billion tons of water per year. And it takes about 2,700 liters to produce the cotton used for one t-shirt, which is enough for one person to drink from for 900 days. So the processing of cotton textiles, which includes the spinning, dyeing, and finishing of the textiles, requires an additional 100 to 150 liters of water per kilo of fibers. So some of the major cotton producing countries, such as China and India, are already experiencing problems with water scarcity, and the production of cotton is a major factor in the mismanagement of freshwater resources in many Asian countries. So in the future, this can lead to even more issues with water scarcity. Additionally, as cotton doesn't absorb dye very well, it's also heavily treated with chemicals during the dyeing process, and cotton spinning can require a lot of energy as well. And cotton has an exceptionally high carbon footprint, as large amount of greenhouse gases are released in the production of cotton garments. So how do we minimize these impacts? So as I mentioned before, there's a large problem with end-of-life waste of textiles, and only a small share of textiles are being recycled, but most ends up in the landfill. So fibers from textiles have been traditionally difficult to recycle, and it is estimated that 92 million tons of textile waste is generated globally every year. And this is expected to rise to almost 150 million tons in 2030. So currently, about 55% of global fiber production is fossil-based virgin materials. 36% is from renewable materials, 8% is from recycled PET bottles, and 1% is recycled pre or post-consumer textiles and other non-bottle feedstocks. So less than 1% of pre or post consumer recycled textiles are being reused for similar applications, such as garments. And another 12% of textile waste is being reused, but for other lower value applications, such as insulation materials or mattress stuffing. However, the far majority of textile waste ends up in the landfill or incinerated. Especially natural and bio-based fibers have shown to be difficult to recycle, as traditional mechanical recycling methods lead to major reductions in fiber length, which has resulted in fibers that are too short to be spun into a yarn of proper strength. And the increasing use of mixed fabrics has also made the recycling process more difficult, as these fibers will have to be sorted and separated. So there are various difficulties to recycling garments. In many cases, there is a lack of continuous and homogeneous stream of post-consumer and post-industrial textiles. There are also problems with the contamination of textiles from wearing and washing of post-consumer textiles, but also from dyes, additives, and other non-fibrous materials such as zippers or buttons. And these materials will have to be removed in order to properly recycle the material in many cases. So the use of mixed fabrics also makes recycling more difficult. And for example, many blends use elastane, which is then only present as a very small percentage, which makes it difficult to remove and also expensive to remove. And sometimes there are no suitable recycling processes available, or not at the right scale, such as an industrial scale. So this could make the process very costly, making it more attractive to buy virgin materials. So we can also minimize these impacts through legislations and through policies. So in the EU, there is the strategy for sustainable and circular textiles, which includes creating more durable, repairable, and recyclable clothes that are to a great extent made from recycled fibers and are free from hazardous substances, but also respect social rights and the environment. There are also different sustainability certifications and standards available for textiles, which can range from organic to fair labor practices. So for organic certifications, oops. There is the organic content standard and the global organic textile standards, which are the most popular, but also Cotton Made in Africa has its own organic certification. There are various social responsibility criteria that can also be included in these standards, such as fair trade. Oecotex Made in Green has this as well, and this ensures that there are fair labor practices throughout the entire supply chain, as well as environmentally friendly production. For recycled textiles, there is the recycled claim standard, which aims at boosting the use of recycled materials. And there is also the global recycled standard, which ensures that the process of recycling products is done in a more environmentally friendly way. Um, there are also various animal welfare standards, such as the responsible standards from Textile Exchange that protect the welfare of the animals in the production of wool, mohair, alpaca, and down. Um, and there are also standards that look at the type and the amount of chemicals used in the production process, which is included in some of the Oecotech standards, as well as in the Green Screen and Green Card certifications. There are also certifications which are more integral and include multiple of these items, such as the EU Ecolabel, the Made in Green, and Blue Sign. Um, so environmental impacts can also be assessed in order to find products and materials with a smaller environmental impact. So to do this assessment, various methods can be used, such as the environmental product declaration, the product environmental footprint, GHG protocol, the Science-Based Targets Initiative, the Hague Material Sustainability Index, and life cycle assessments. So LCAs can be used to assess the environmental impact of materials, products, and services through every phase of its life cycle. And it can be applied to a wide range of industries, including the textile sector. So it can be used as a decision-making tool towards sustainability. However, to compare the environmental impacts of two or more products and choose the most sustainable option, the ways that this is measured has to be done in a similar way. So as such, the Align project is looking at LCA methodology and aims at improving, harmonizing, and aligning LCA assessment methods in the bio-based sectors. Yeah, and we want to get your opinion about all of these things, which is why after this we will have the interactive discussion. But first, this was my presentation. Are there any questions now?
Yeah, thank you, Marissa. This was very interesting, very thorough, of course. There was several interesting comments were made at the chat.
Okay,
So I propose that we first do those, and
perfect.
afterwards we can do some other things.
Mhm.
I'm just picking out the most the most clear points. The one first is about the occurrence of microplastics in an LCA. That was done by Mrs. Claudia, Claudia Som. Thank you for this addition. What I propose, it's not really a question to you, Marisa, but I propose that we discuss this later in the interactive discussion. We will have something about the environmental impacts. Then the second comment, and that's, I think, a good one. It is about the cotton production. Nikki stated, well, it's a bit one-sided. Yeah? There are also apparently regenerative ways of growing cotton, more sustainable ways of growing cotton. Can you say something about that?
Of course. At least in the textile or in the sector overview, we went a bit deeper into this because, of course, especially if you produce organic cotton, there are so many ways to make this process more sustainable. A lot less water is used, so this problem becomes a lot smaller. There are no synthetic pesticides used, so a lot of these issues, yeah, are not as bad. So you are definitely right that I did not mention that during my presentation. Yeah, so of course it's not all wrong, but conventional cotton has many environmental impacts, or big environmental impacts, which is why I wanted to state that just because it's bio-based, it's not necessarily very sustainable, but it can of course be produced in a more sustainable way.
And Marissa, you have you all also included this in the report, that
Yeah,
not everything is bad
of
with
course.
cotton?
Yeah, I
Eh?
went pretty deep into organic cotton, most specifically, that it can be produced a lot more sustainable. Yeah, so this
Okay.
is included.
Okay, that's good to know, and thank you, Nikki and Rosemarie, for mentioning this. Then there's another question about the water consumption for cotton production. Nakata Pranav asked if the water consumption, if it has to be fresh or groundwater, because it's mentioned that there are studies on the use of industry recycled water for cotton production. Can you say something about that, Marissa?
I am not completely sure. I did read about this, and that most of the water used in cotton production comes from nearby lakes and waterways, but I am not completely sure.
Okay, okay, good. That could be also a way of discussing in the report ways to improve the environmental sustainability of cotton production.
Yeah.
Because it is, especially for the conventional cotton production, it is an issue that I think nobody disputes that.
Mm-hmm.
And ways to improve that are, I think, yeah, well, could be well received. Then there is a bit more practical question, and that is about, yeah, earlier you had a pie chart on the use of fibers.
Okay.
Some fibers were fossil and some were renewable. I believe
Uh,
1/3 was
the
renewable.
feedstocks?
Yeah, if you see it, then I know what. Yeah, this one.
Okay.
And the question was, what falls on the renewable materials?
I would say it's most bio-based materials that
Okay,
are renewable. Yeah.
so when it's bio-based, you say it's renewable,
Yes, and
and
this
that's why it's
includes this. I think this is only the virgin renewable materials.
okay.
Yeah.
Very good. Yeah, for me it's clear, but Lisa, if you have additional questions, please ask them. Good. I think those are the most pertinent questions from the chat. If there are any other questions related to the answers provided or otherwise, Lisa, I see your hand.
Yes,
Wonderful. Thank you for using it. Please go ahead.
yeah, thank you. Just to follow up on my own question about the renewable materials. So does it also contain like polylactic acid and these yeah, these bioplastics, let's say?
Yeah. They are
Okay.
of course not included in the virgin fossil based. So I assume I have to look at the source to be completely sure, but I assume it's not included in the virgin fossil based. It should be in the renewable materials. But of course, this is a very small share of feedstocks used. Yeah.
Okay.
Okay, thank you for clarifying.
Good. Then Claudia, you also used the very good hand mechanism.
Thank you so much. Very nice presentation. Thank you for the invitation to this workshop. So I'm a little bit now thinking about, because of public procurement, there they ask a lot of that the rate of recycled material, the share of recycled material is given by the suppliers, and this is very highly rated. I mean, I have to say from our LCA experiences, the the durability of the textiles or the adapted lifetime is much more important than anything else. Yeah, so even also what you discussed now about organic cotton and conventional cotton. I mean, it's good to go for better improvements there, but it's somehow marginal. Yeah. So, and I'm just thinking, because also Switzerland, they want now to do some guidelines for public procurement. And I know also in the EU, there is a document on public procurement, green public procurement. And what you also showed that a lot is coming from PET bottle recycling. Yeah. And there, actually, do you really solve a lot of problems, or do you rather create problems? So, yeah, I'm just wondering, and also I discussed it with the textile labels a lot. I said, why do you not also label the durability of textiles? Yeah, because this is the key issue. Yeah, that you can use a textile as long as possible. And you also mentioned that the fast fashion, yeah, this led really to an increase of all these environmental impacts. Yeah, so I just wanted to know also your opinion somehow, because I will give the feedback to the Swiss government. I mean, that's nice to have recycled material in it, but it has to be sure that you do not use more energy for the recycled material than for virgin material. You also have to assure that you can recycle it multiple times without losing quality. And then also telling them they should really still force to show the durability, yeah, of the textiles. That this is really the key issues. And I also was thinking from a perspective of a company. I mean, what can a company nowadays do? Yeah, the industry. I mean, there is just a PET bottle polyester, recycled polyester available. They are not able, an SME, you also said most of the textile companies in Europe, they are SMEs, they cannot establish a recycling system themselves. Yeah, so I mean, they depend on what is on the market. But yeah, I just was wondering, what is your opinion about these public procurement guidelines? Sorry.
I think you have a very good point that, of course, even if the product is produced very sustainably, but if it falls apart after 5 uses, it is not worth anything. So I think the durability is very important, and this should be labeled or certified in some type of way. I'm not completely sure how to do that, but maybe one of my colleagues or Jean-Luc or Stijn can comment on this.
Yes, well, I can talk about the Dr. Green project we realized at Utrecht, and this is something that is already available in industrial quantities. It's not a kind of prototype. So one of the main issues of the success of the project is that the garment, the lifetime of the garment is also guaranteed to survive at least 100 washes, because it is a garment that is used by industrial launderers, and they of course are interested in garments that have a long lifetime. And that is also why we added. So in the product, there is about half of the fibers used in the product are recycled fibers, but we needed, of course, to add some virgin fibers. So we added some polyester from bottles. So this is a kind of recycled. But for the textile processing, we can consider that as virgin. And we also added virgin organic cotton. Why? Because after 100 washes, your cotton, even 100 industrial bleaches, the cotton returns to dust if you want to shred it again. And so the addition of that virgin cotton enables the product to survive again 100 washes. So this is by when you design such a fabric, you have to take into account indeed the lifetime of the garment. Otherwise, the exercise makes no sense.
Thank you.
Yeah, thank you, Jean-Luc, for this contribution. We are already starting a little bit in the interactive part. However, we would like to structure that a little bit, and we have for this nice app. It's called AHA Slides. And Marissa, please tell us how to do it.
So it's
Yeah.
it's not an app, Patrick. It's a website which you can find on your phone. So you can either scan the QR code, and it will take you to the website. And here it works similar to Mentimeter. You can vote for different answers, and we will also have some open answer questions on which you can type and then submit the answer. Or you can go to ahaslides.com and fill in W Textiles, and you will also get to the same site. So one thing to note is that sometimes when we go to the next question, you might still be stuck on the last question on the app. So then it will say go to slide at the top of your screen. But we can start with some trial questions just to make sure you all get the hang of it. So let me ask you, what is your field of occupation? And in the meanwhile, the QR code and the website is still shown on the screen if you haven't joined by now. But I see 9 of you are already there, so that is great.
Yeah, and the general idea of this exercise is we will have a few questions on the environmental sustainability. We will show what each of you think. We will show what the consultation brought to it. And the idea after that is to have a discussion on or say some points with respect to these results. So it is also a bit of a conversation starter. 9 people, you said?
12 now. And
12,
I think
okay.
9 people have voted. So I see most of the people are from research, and we have some consultants and a textile processing. Someone is there as well.
Yeah. And I also see people at the bottom. You have some of these icons which you can use. It's there just for fun. It's you can use as many as you want. Please don't, but you can.
It's fine.
Yeah, but it's fine. It doesn't have any implication whatsoever. Is there anybody who is having trouble with going into AHA Slides?
Yes, me. I'm sorry. Somehow I can't open it.
Oh, we'll just wait.
If it's not working on your phone, you can also go to the website on your computer as well.
Okay, I try. Don't wait. I just try. Yeah.
Okay, we have another trial question, so should be fine. So in what country are you located? And this is in the form of a word cloud. So here you will have to type your answer. So many people from Belgium.
The Belgians are fast. That's
Yes.
what you see. Yeah.
The UK. Yeah. The Netherlands. Okay, I think 14 out of 15 or 14 out of 14 have voted.
Okay,
so
that's good.
Let us continue to the real questions. So first, what are, in your opinion, the most important environmental problems of the textile sector? So you can choose 3 of these options. So you can choose from microplastic release, the consumption of fresh water, the generation of waste, fossil fuel consumption, the emissions of greenhouse gases, toxicity of pesticides, also includes insecticides, the toxicity of processed chemicals. You can choose from land use issues, and if there are any other environmental problems that we haven't mentioned here, you can also use the other button, and then it would also be great if you could elaborate on why. So while all of you are voting, should we show the responses of the consultation, Patrick?
Yeah, please. Yeah, just to, yeah, we can go back after that. It's,
Yeah, of course.
Yeah. Okay. Yeah,
Yeah,
please
so
do.
in the meanwhile,
Yeah.
you can still vote, but we asked the same question during the online consultation. And here we ask people to give a score of how important they find these different environmental problems. And we found that most people found freshwater consumption very important, as well as the emissions of greenhouse gases, the toxicity of processed chemicals, and the generation of waste. But the people from the consultation found the release of microplastics, the consumption of fossil fuels, toxicity of pesticides, and land use. They found this a bit less important. And let's see what all of you.
Yeah, a bit less on the freshwater consumption.
Yes.
Which, I mean, my idea is if you look at this cotton production, the freshwater consumption there is really an issue. My personal opinion would be that fossil fuels and emissions of greenhouse gases is a bit less of a problem, in the sense that it is now a problem, but it is solvable when we go to net zero in a number of years. Then the textile sector will go along. They will have to in some way. But that's just me. Is there anybody who wants to comment on any of these environmental issues? Fiona, please.
Hi there.
Hello.
Yeah, my name's Fiona Ford, and I'm a PhD researcher at the University of Manchester, and I'm doing an LCA of polymer recycling of bio-based materials, so very much aligned with your own research. But yeah, I find it really difficult to comment on this. It's such a macro view because, like we were saying earlier in the presentation, you're right, it's product specific, it's material specific. So, you need to look at what the impacts of those are. So I can't comment. I find it difficult to comment on this overall. So I would want to look at materials like cotton or polyester and what are the impacts there. And then also the whole, if we're looking at the whole life cycle, like Claudia was saying about quality as well, you need to think about at the garment level as well. That's why it's important to kind of break it down. And I noticed that a lot of LCAs are looking at 1 or 2 life cycle phases. And I think that has value because, it's modular and it breaks it down. And you can start to kind of put the pieces of the puzzle together that way. But to comment on this, I don't know how meaningful it is. Because, I mean, I was just looking at a study that I've got in hand, which is a systematic review of the life cycle clothing inventory, which is, obviously very much a macro view. It's the type of study. It's what do you call this? It's it's a macro systematic literature review, and I can't get it out of that at a glance either. And I've read this cover to cover as well, and I don't remember getting an answer from it.
Yeah.
It's not there. So yeah, we need to be careful about this kind of and analyzing this kind of macro analysis, I think.
Yeah, I think thank you for your comments, and I think they're very pertinent, especially in the sense that we are taking it very big, and even in our projects we are taking it even bigger, in the sense that we are not only look at textiles but at 5 sectors, and of course you are right. It is difficult and yeah, practically impossible, you can say, to have this view and know everything. Who doesn't? But the point is that we want to do that anyway, because it is important to also look at these bigger pictures, because these sectors influence each other. And the textile sector, the different uses, the different ways in which all these value chains, these interact with each other. So it's also good to know what are overall effects. And it's also good to know, to have an idea on where do you look for the issues, what are the most important things, and not only, you should also look at all the details and all the detailed garments, products, etc. But you should also have the overall environmental idea, on what is happening in the sector. So your critique is very pertinent. But we, as I said, we think we also need to do this. I hope this answers more or less your question. Rosemarie, we have heard and we read already a lot about you. Please let us hear your voice.
Yeah. Hello, and thank you for having me.
Thank you.
I truly want to add something we discussed already in the chat about the freshwater consumption. I worked for the Fair Trade organization on cotton, and what is very important that the cotton will be rain-fed or there's no harm for the environment. And by regenerating the water from a lake like the Aral Lake, or some that the farmers has to choose, or do I need the drinking water for my family, or I have given it to my cotton plants? That is a big issue. And what I pointed already out, that we have really to do the research and to come up with results that the harmful places where we grow cotton nowadays, while the ground is not made for it to grow cotton, that we have to point out this to everyone. So cotton for so many years, so it's there for 6,000 years, was never a problem. And suddenly there's a problem, and it is because of the GMO, of the pesticides, etc. So the important thing is that nowadays cotton is seen as a bad material, but it's not a bad material.
Okay. Thank you for this contribution. That's very good. Yeah, it's in more a general comment. It's very good to take this along. We will have to look at the report a little bit also on the cotton. We talked about it earlier. It's never only bad or all bad. So we will take this comment also with it.
In the case of the Aral Sea is also included in the sector overview.
Yeah. Is it a good moment to discuss the microplastics? There was a comment on the chat. Maybe the one that made the comment, I believe it was, let me see. How did it? Oh, I didn't have the name, but there was somebody in the chat who made a comment on microplastic. Do you want to say something about that? No? Okay. Yeah, well, then let's go on to question number 2.
Okay.
Oh, Claudia, I see a remark from you.
Yeah, I think it was somebody asked the role of microplastic in LCA, and therefore I gave our study. We did a study 2 years ago where we looked at a T-shirt and then tried somehow to establish the worst case, also for the characterization factors for the LCA, and then to see if this microplastic emission somehow show up in the end result of an LCA, of a T-shirt from polyester for freshwater. Yeah, and there we saw that this is not the case. It seems to be not so relevant. Yeah, I mean, you can't show with an LCA then the relevance of a microplastic emission in fresh water. So that we did in this paper. But I don't remember who had this question. Sorry. Oh yeah, it was.
Yeah, but the point is, what was made was the microplastics do not indeed show up in the LCA, and what you say means that that is correct. Huh?
For freshwater, yeah, for the freshwater emissions. So we
Okay.
thought maybe in soil it can be different. So we plan, if we have the chance, to do something for the soil also, because we do a lot of microplastic release in the lab from the textiles, and we do also modeling with material flow analysis of polyester and so on, and see what is then expected to be released in different environmental compartments. And then also do a species sensitivity analysis, so like a review on toxic data, and see if there's really a risk for specific environments, for specific polymers, on microplastic. So.
Okay, good. I think we take this along. I mean, this is one of the inputs that we gather. Should we look at these microplastics? Apparently we do. We have to. Thank you. Let's go to the next question. The environmental impact methods which you are using.
So you can, of course, choose multiple ones or all of them.
And this is just a way just to check with so that we know a bit what are the assessment methods which people are actually using when they are working in these when working in the textile sector.
So are there some assessment methods that I forgot on here? I see some people that are answering other.
Lisa, you have a hand?
Yes, I have a comment on that. I also added other because we are also doing social LCA or trying to apply it to the textile sector. So that's why I added that.
Okay.
Because I feel like life cycle assessment is focused on the environmental side and not really the social side.
Yeah, I think that's many people will agree with you. The LCA is a very a technical way of looking at the world. Pedro, you also have a hand?
Yes, I also added others because I'm using material flow analysis as well. And I also use the life cycle screening of emerging technology, which is a new methodology for assessing on more like a qualitative layer, you know. And this is very good for new materials that you don't really have enough data to perform an LCA. So yeah.
Yeah, that's interesting. How do you how was it called? It was called Emerging Life Cycle Assessment.
Yeah, it's life cycle screening of emerging technologies. The name is LISET.
LISET. Yeah, life cycle screening, LISET, life cycle screening of emerging technologies. Okay, interesting. Okay, that's I think a very good thing, especially for bio-based materials, because yeah, usually there are new or newish, and then indeed lack of data is often an issue. Thank you for this addition. Maybe Marisa, can you show what the consultation people said?
Yes. So almost all of the participants of the consultations are working with life cycle assessments, and the majority also works with the product's environmental footprint, and their some smaller shares for the environmental product declaration, environmental impact assessment, science-based targets initiative, GHG protocol, and one person was working with the Hague MSC, and one person with no environmental assessment methods. So
Yeah,
I
that
think,
shows that. I mean, this is always it's always an incomplete subset, but life cycle assessments and the more simplified way of that, the product environmental footprint, they are quite prominent. Diego, I see a hand for Mr. Diego Penazoa.
Yes.
Hello.
Yes.
Welcome.
Thank you.
Welcome.
My name is Diego Peñalos. I coming from Rice in Sweden.
Oh,
I've just
okay.
wonder about, because I think it's a bit misleading to have LCA and PEF and EPD separately, because LCA is a very it's a very broad concept, or it's more a tool, and then when you carry out a study based on PEF, then you are also carrying out an LCA, and then when you carry out a study for an EPD, you also carry an LCA, and that's I just think there is like a conceptual juxtaposition maybe there. I wonder what are your thoughts about that?
Yeah, well, the issue is certainly very much true. It's all ways of doing LCAs. Yeah, we wanted to have this separation because we just wanted to know how are these deviated methods, how are they used? If they would not be used at all, that's a signal. We trying to simplify LCAs, and PEF and EPDs are ways to simplify it. If that doesn't work at all, I mean, what's happening there? Huh? It's good to know that at least. So that's why we try to ask this as well. We think this completes the picture a bit more about the use of these methods in the field.
I think there is a very relevant thing to ask, but maybe make the distinction. The LCA, I don't know, because a lot of people seem to think that PEF and LCA are opposites.
Yeah, and they are not. They are not, certainly not. Thank you, at least for thank you for this. Can we go to the next question?
yes.
And
So go ahead,
yeah,
Patrick.
Yeah. We take this question, and after that, I think, Marissa, we should go to the last question, which is an important one, namely what you want us to do, the Aligned project. Yeah, because we are not going to finish it. That's, I think, not a problem. I think these questions are also conversation starters. But it's I'm this last question, however, I would like to have it. So after this, we go to the last one.
No problem.
This one is about the challenges of verifying environmental sustainability. So not the environmental sustainability as such, but how do you, what are the challenges you have with respect to verifying it?
Should I show the responses of the consultation fast while all of you are deciding? So from the consultation, we also asked the participants to give a score of how important they found these challenges. And we found that data availability appeared to be the biggest challenge, as well as the data reliability. So this biggest issue appears to be with the data. There's also the issue of supply chain complexity, as of course a textile supply chain is very complex. Then there is the inability for outsiders to confirm these claims, as they could be confidential, but it also could be very difficult to understand. There is the issue of time. There are many different standards and systems. They could be unclear to the customers. And we found that the costs and that the definitions are unclear were seen as less important to the consultation participants. Yeah, and here we are seeing some similar results as the data availability and data reliability appear to have the appear to be some major challenges.
And is there somebody willing to comment on that? Why is this specifically for the textile sector difficult to get data? Is it because the international value chains or the industry specifics?
If I can react, because we face the same problem, because I am the coordinator of the denim deal, and it's more the willingness to share the data. The textile industry is a non-transparent industry, where the oil industry is willing to share oil when they needed the gallons, etc. The textile industry is not willing to share their supply chains. And I'm 40 years in business, I never understood it.
So it's not clear to you why they don't want to. Is it because they want to protect the knowledge, that they don't want to tell others where they get their materials from?
This is the reason what they share, but I can't imagine, because when someone is working more than 2 years into the brand or the industry, they hop to another brand, so they are taking with them all the knowledge as well. So for this, I never understood why they are not willing to share the data.
Okay, interesting. Yeah, and you say actually they do share it via recycling their own employees to different companies. Maybe not willingly, but in practice they do. Interesting. Any other comments on this data availability and the reliability? Lisa, please go ahead.
Yes, it's not really about the data availability and the reliability, but I'm very much on board with this, that these are major issues, because I'm also a researcher, and we face this as a big problem, not only for the primary data, but also secondary data, that databases are not very elaborate on these processes, or that it's not really reliable information. But I wanted to make a comment on all these issues. Now they are put together, but I think they are also very much dependent on who is answering this question. So for the industry, it will probably be more like time and cost as major issues. And then for industry or for consultants, it will be this data availability and this reliability. So maybe it's a good idea to divide these into the different groups or participants, let's say, to have a clear vision who who with their roles have these different issues.
Okay.
Just a small side remark from my side.
Yeah, that's a good idea. We also we also record the sector where people coming from, and we can make a nice cross check with that. So that's indeed interesting. That's a good idea. Thank you for that. Good. Then I would say let's go to the last question. Yeah, we miss a bit of nice questions, but too bad. This is about us. We would like to improve the assessment of the bio-based products in the textile sector. And yeah, there could be ways in which this can be improved. I know this is a kind of a word question, so you can answer questions. It may be a bit difficult, so Marisa, can you show already some ideas what came out of the consultation?
Yes, from the consultation, we found that many people told us to account for land use changes in the LCAs. There were also some other comments, such as they want standardized methodology, to include indirect land use changes, to create standards for CO2 uptake, to engage with stakeholders, which of course we are doing today. So yeah, and it was interesting as some participants asked to give more standards, and others told us to not introduce any new standards as there are already so many available. Standards for carbon sequestration, to not be influenced by lobbies, to compare among standards and to cooperate among these different standards.
Okay, that's interesting.
Yeah.
I would say this standard on the CO2 uptake. I assume that means that when you use bio-based materials, they take up CO2 during their lifetime, and it's difficult to account for that in an LCA. And that's probably the background there. Apart from that, we had a remark on the microplastics. I don't see it here, but we heard it earlier. So that could be a good thing to also take into account. Okay, people already have given some things. The land use, I see again. Data availability, that we just discussed this about it. Create an open database, collect primary data. That's all very much related to the data availability, I see. Yeah, the water consumption, yeah. And avoid consequential LCA. Again, there are people who really don't like consequential LCAs. Yeah. It's I must say that we are not very much involved in the methodology part of the project. Others are. From what I hear is that people are really thinking of trying to look at consequential LCAs. We will bring this in. We will say, well, not everybody in the sector is happy with that. We see that in the consultation and already in the workshop. So we will give this signal certainly. It would be helpful if the person who said this can say why. And that's a question. Okay, you can also say it in the chat. If you say, please don't do consequential LCA because, I don't know, it's more work or it is more difficult. I don't know. Okay, we have to do it with this. A lot of. Okay, a lot of things. Yep. Yeah. A lot of things has been said here. It's very nice. Product durability. Data availability comes big. Yeah. Do not add new standards. That's clear. Harmonize with the PEF. We will try to do this. We see it as a very good way of trying to simplify methodologies in certain sectors. It has its drawbacks, but what hasn't? And the effort is, I think, very laudable, and we would like to contribute to that. Okay, thank you very much for all your comments. Great. Does anybody want to have any wants to add something to what they wrote? Please do. And we are already very happy with all your suggestions, sir. But if anybody wants to elaborate, please do. We now still have some time. Fiona, please go ahead.
Hello again. It wasn't my comment about the consequential LCA, but I have been reading around consequential LCA, and what I have noticed there is that well, when it comes to material recycling, you're talking about analysing replacement rates of materials. So replacing one fibre with another, and if you're looking at the recycling of like polymer recycling of cellulose. Oftentimes you're looking at, you know, this regenerated fiber, this regenerated cellulose fiber which comes from it. It's the assumption that's being made is it is replacing cotton, right? And there's like some academics are kind of like arguing that because like there's kind of similar properties there, physical properties there, that is a suitable replacement for cotton. But I haven't come across any empirical research of any kind of qualitative nature and like with product developers, you know, that have assessed whether or not like you know, they would be willing to make those changes. So I think that's something that I've picked up on there about consequential that isn't making sense to me, particularly as I'm coming from a product development background, right? So that's something that I'm maybe going to look into with my PhD project.
Nice. Yeah,
but that's not confirmed yet.
May I distill it in the sense that a consequential LCA, you are not looking at the product itself and its impacts, but you're actually looking a bit further at what it replaces. That is a difficulty because it's difficult to know what the specific sector characteristics are. Is that the
like
short?
you say, it depends on the product. It's like you need to then look at specific product categories, I think. You know, if we're talking about can a regenerative fiber replace a cotton fiber, then we need to again be looking at the product level. Are we talking about in denim product? Are we talking about in like men's shirting fabrics? Are we talking about in jersey? Because each of those, the fiber will perform differently. And, you know, in the case of maybe mercerized cotton, which is used quite a lot in men's shirting, but also in home textiles as well, there is a possibility that something like lyocell, in my opinion, could replace mercerized cotton. But in other applications, because there's this kind of like more fuzzy texture to the cotton surface, there's a lot more kind of like slippage that happens and kind of drape with the kind of regenerated fibers, which, you know, coming from that product background, I don't think it's a suitable replacement. And I don't think that, you know, if we were to survey those in industry, I'm going in thinking that, you know, the opinion is going to be reflective of my own. So,
okay, thank you for this. That's also thank you, Diego, for the clarity. We will also take that along. And just as a last thing, Nikki, you have a hand, please. Would you care to share something?
Yes, thank you. I would like to react on Fiona. Fiona, if you talk about regenerative fibers, are you talking about recycled fibers? Because what we are doing is we grow fibers within a regenerative food and fiber ecosystem. And that's why I put in this chart context base. I think it's such an important detail that if you talk about those kind of fibers, the way they have been grown, in which part of the world they have been grown, so that you really look into the context they have been grown. Yeah. That is what we call regenerative fibers. Yeah. Fibers from regenerative agriculture. Yeah. And right now I see a mix up of using the word regenerative for blunt recycling. Do I understand you correct?
Yeah, so regenerated cellulose is a type of cellulose that it was highlighted in the presentation from Marissa. It's man-made cellulose is another way of phrasing it. It's when you take bio-based feedstocks, usually like conventionally from forestry, and they're treated and then they're extruded and they become, so that's the regeneration process. So in the field of in that sector of textiles and the circular economy, in recycling, it's referred to as regenerative, but I'm much aware about the kind of the regenerating natural capital aspect as well. Yeah, so and it's another kind of broader kind of definitions problem in circular economy, but it's, you know, it's not something that I'm responsible for, don't get me wrong. Like
no, yeah. Thank you, but I just wanted to have mentioned it. Thank you.
Yeah, okay, thanks.
Okay, well, thank you all. We are now a little bit over the time already, so we really need to answer this because people have other things to do. We are going to wrap this up. I would like to thank you all for your input. I hope that we have given you useful information on what we're trying to do and on the sector. We hope that this helps you in your work. We are grateful for your input. We have learned especially certain things which can be used in the sector overview and can be used in our work. So thank you for that. We will make a short, concise report on the consultation and on this workshop. We will send it to you all also so that you may use that the way you see fit. And yeah, as a last thing, I would like to, if you have not already done it, please be a stakeholder, join the stakeholder network. We will keep you informed. We will not flood you with all kinds of things, but we like to keep the information targeted and not too much. But when we give information, then it is useful and interesting so that we can take you along in our journey. Thank you all. And all have a very good day.
Yes, thank you all for listening. And
Thank you so much. Bye bye.
Okay, thank you all.
Bye-bye.
Bye.
Thank you.
Thank you. Bye. Bye.
Bye.